know that there's like 9 million other things you could be doing right now. So I'm really, really grateful that you took the time to be here with us today. I wanted to introduce Susan Resnick, who's going to go through the math with us. She's one of the authors of the math program that we use, Math in Focus. Take it away, Susan.
Okay, thanks. Well, welcome to Parent Night. Thank you guys for coming out. I know it's a busy time of year. Back to school night probably wasn't that long ago, right? So you probably just did that. So I really appreciate you guys coming. But our goal for tonight is really pretty simple. You know, you might, hopefully, and by the way, before I do that, by the way, you are welcome to reach out to me after if you have questions. So I have a website that has some resources about Singapore math. My email is right below that. It's pretty much the same thing. There is a Facebook group if you're super interested in that, and then that's my Twitter. So we're going to use the terms math and focus and Singapore math a little bit simultaneously. So you might wonder why it says Singapore Math Night. So this is actually the national curriculum of Singapore. So we're going to talk about that a little bit and how that came to be and why that is. But really our goal is so that this is not what homework feels like. Okay? We don't want math to feel like this for you, for your child. And coming out of the pandemic in particular, if you have older kids, you know, you might have experienced some of this when they were home with you, which actually reminds me, how many of you are kindergarten parents? Okay, good. In first grade, second grade, third grade, fourth grade, fifth grade? Okay, good. All right, so our goal, you know, for math should be for the kids and you to be having more of this experience. It's like a feeling of wonderment, a feeling of enjoyment, a feeling of discovery, and that's really our goal for math, okay? And so what we're here to do tonight is teach you a little bit about Singapore math, why we're doing it, what some of the teaching strategies are, and then give you some tips about how you can make this into an enjoyable and fun and fulfilling experience together. But I'm going to tell you it is not how I learned in school, and it's probably not how you learned either. So it's going to feel a little different for you, okay? And you might feel, a little uncomfortable when you see something come home that you've never got to experience. Our goal is to help you sort of be able to anticipate and think about some of those things. All right, so we're going to start by just talking about like why in the world is Arlington Heights School District using a program from Singapore. And the first thing to think about is like, where in the world is Singapore? Okay, so does anybody actually know where it is? You know where it is? Can you come out? Come on, maybe we're just take a generation. No, I'm just kidding. Come on, no. Okay, so you're gonna point to it. And I noticed not so many people volunteered, so we're gonna like cheer you on. Okay, so where is Singapore? Okay, keep your finger there. Oh, that was very, very good. Wait, should give you. I think it is important for people who haven't been to that part of the world to like understand where is Singapore. It's not like near Japan, which is what I think a lot of us might think. It's closer to Malaysia. As a matter of fact, they share an island with Malaysia. It's separated by a bridge. It's absolutely tiny little country. Okay, and it's important to kind of know a little bit about the history of Singapore to find out like why we are using a program from Singapore, and as are many districts in this area. Just so you guys know, it's pretty popular here. Okay. It was, but this is a new edition, so we'll talk about that a little bit too. It's rewritten. Oh, yeah, and we'll talk about why actually. Okay, so this is what Singapore looked like around 1980, and it was a pretty poor country at the time. It had a low per capita income, okay, and they had just become a country, right? They're about 55, 60 years old in the country. I think just 55, maybe they just celebrated. And that's kind of what it looked like. And what happened was the Prime Minister of the country, the Minister of Education, kind of got together and said, what can we do to turn around our economy? And something you need to know about Singapore is they don't have any natural exports at all. Okay, so they even import water. So they said the only thing we can do to improve our economy is to improve our educational system. So what they did was they went and they studied the best practices in math and science from around the world, and they came back and they built their national curriculum. Okay, so what happened? Well, this is what happened. This is Singapore today. Okay, they completely turned around their economy. They now actually have the highest per capita income in the world, average per capita income. They, how many people here, does anybody here have an office in Singapore? Okay, many of us have offices in Singapore, right? And they really became a global hub of economics and business, right? So how did they do that? Like you said, they just changed their curriculum. And if you ask them, like, do you use Singapore math in Singapore? They say no, right? Because to them it's just their curriculum. We call it Singapore math, but they don't call it Singapore math. Does that make sense? To them it's just their national curriculum, okay? So let me talk to you a little bit about that. Before they did this, they were 16th in the world. Now, like I said, they are #1 in the world in mathematics. They have been for about the past 15 years, okay? And let me show you a little bit about why. So you might have noticed that you have paper and pencil in front of you. It is your turn to do a math problem, okay? I want you to think about this. You do not know any variables because you are 8, okay? You are 8 years old. Put yourself in the mindset of a 3rd grader, all right? Try to solve this problem the way a 3rd grader could solve this problem. So go ahead, take a minute, talk to the person next to you. Go ahead and try this problem. You get paper and pencil. And I want to hear, like, what are your strategies, or how did you approach this problem? So some of you have cubes, right? Did any of you actually use your cubes to solve this problem? Okay, good. How did that help you?
This is where I'm terrible with explaining how it works, yes. So I knew that this was the number of girls, so I counted out 8, and then I needed twice that many, so I measured out the same number twice. And then I just counted the cubes.
Excellent. So you made 8 cubes, right? And then what did you said that represented what?
The number of boys.
The number of boys, okay. And then you said you knew you had twice as many, so you just basically did that twice, right, with your cubes? Okay, excellent. And then how did you finally get to your answer?
And
Counted them all,
Yeah.
starting at 1?
starting the boys, and then I counted the girls.
Okay, did you just say 8 and count on, or did you say 1, 2, 3, 4?
I multiplied in my head to an 8-year-old, and I probably counted them individually.
Okay, so you had 1, 2, 3, 4 until you got to 24. Okay. All right. That's one way to do it, right? Okay, does anybody have a different way that they approached it? What did you do?
Then 8 times 2,
What did that represent?
that would be the girls,
Okay, so you said the girls was 8 times 2.
then added the 8 to that, the original 8 boys.
So did you find 16 first?
16, yeah,
Okay.
16, and then plus.
And then added the boys back in and got the same answer. Okay. Anybody do it a different way? Yeah?
So I assume the number of boys are X.
Okay. So instead of X, because it's 3rd grade, I'm just going to draw a box. How's that?
Yeah.
Okay.
So my girls will be 2X.
Okay, good. So if the boys 1 box, the girls would be 2 boxes. Do you see that? You guys agree? Okay.
So there will be 3 boxes.
So there'd be 3 boxes. And how much is each box worth?
Each box is
8, right? Each box is worth 8, right? Okay, and then now what?
Just add 3 boxes.
Then you just added 3 8s. Okay, so 8 plus 8 plus 8, and that was 24. Okay, so you basically found this, right?
So basically I did what X plus 2X is 3X. So
Exactly. Isn't that exactly what you did? X plus 2x equals 3x. Okay, so we're doing pre-algebraic thinking. Did anybody do it a different way? I think you said you did this, but you showed me this way. You said you just figured out that it was 3 times 8. Right? Is that another way to think about 8 plus 8 plus 8? Another way would just be say it's 3, and then to the kids we say it's 3 groups of 8. Right? Which which is 24. Okay, so we came up with 4 ways to do it, and there's probably more ways, okay? So what happened when this question was on the International Test of Math and Science in 2019? This is what happened. 81% of kids in Singapore got it right, and only 54% of American kids got it right. Okay? When we give them a geometry problem, this is what happened. 86% of kids in Singapore got it right, and only 22% of kids in the US got that question right. At that point, American schools started to look towards Singapore and say, what is going on over there? What are you doing that we can maybe do here, right? So let's take a look at some data. How many people in here work in a field that uses data? Okay, good. I don't know if you're aware, but colleges are asking our students to take AP statistics over AP calculus now. Why do you think that is?
More useful.
More useful, more kids use it, right? We need it more in our data. Okay, let's take a look at some data really quick. What are some observations that you make about this data? By the way, that's at Singapore, says US. The blue line is the only way we can compare them on the same graph. Okay? It's a line of comparison. So what do you notice?
Singapore's trending up.
Singapore continues to go up. The international average is 500. Okay? So they're well above the international average, but they have continued to trend up since 1995. Okay? What else do you notice?
Their worst is better than our best.
Yeah, their worst year is better than our best year. Yeah, good noticing. It's a little sobering, right? Okay, what else?
When you say the line is 500,
It's 560.
okay.
Ours is trending down.
Ours is trending down. What happened in 2010? Does anybody know in education?
Is that the child?
No Child Left Behind, the Common Core came in. Common Core, I am a proponent of the Common Core. Like I said, I like it. I think we should have national standards. We live in a country where people are highly mobile. It doesn't make sense to me that if you move to Texas, you have different standards than if you move to Illinois or Colorado. That makes no sense, right? We move a lot. Okay, it got very politicized. But what happened in schools, the reason it affected schools is because schools started to interpret it as the ceiling. And it wasn't meant to be the ceiling, it was meant to be the basement. Does that make sense? So we started to say, oh, that's not part of the standards, we don't have to teach it anymore, right? Okay, and that's what happened, that was the way it was used that went wrong, okay? And we started dropping and have been dropping, okay? So why, someone asked earlier, like, why is there a new edition of this program, right? Well, in Singapore around 2007, 2011 maybe, they said, our kids are continuing to grow and our curriculum isn't meeting their needs anymore. We need to think more about problem solving. We need to think more about data analysis. We need to think more about jobs of the future. And they changed their syllabus. And so that's why there's a new edition of this book, because we also changed the book to match the idea of more focus on data and problem solving. Okay? We're going to talk about that a little bit right now. So last thing I want to talk to you about the data is this is specifically in 2019 how Singapore and the US did on 4 different levels of questions. The low level questions are things like simple calculation, like what is 6 times 8, something like that, okay? And there's a myth in the US that our kids don't have basic skills. It's not true, right? Pretty much the same as Singapore on low level basic skills type questions. We do have that, okay? The next kind of are ones intermediate where kids have to apply a strategy of some kind, and we still look pretty good, okay? It's not until you get to questions that require a lot of analysis or a synthesis of things you haven't learned before that we start to drop off the map, and Singapore continues to be at the top. Okay, so that will explain a lot to you about why Singapore math does what it does. So in Singapore, Math and Focus is called My Pals Are Here. It is the largest, most used program in Singapore. It was brought to the US, it was recovered for a US audience. It is still owned by Singapore, the Singaporean publisher, and Hood Mifflin Harcourt in the US has the distribution rights to it. They release on it. Does that make sense? So we use it at the pleasure of the Singaporeans. Okay? And in the US it's called Math and Focus. All right? But yeah.
I thought their original book was way more fun.
This one?
Yeah, I don't think.
Yeah, I think the US, I think they felt like it was kind of babyish for the US. Isn't that interesting? It's very, it's like cute culture, right? Yeah. Okay, so anyway, that's the one that we have here. All right, but we follow Singaporean pedagogy. So this is the heart of everything we do in Singapore mathematics, okay? So what we say is that problem solving is at the heart of everything we do. Problem solving is the goal of mathematics now, all right? It's not calculation, it's not maybe even like solving a bunch of algebraic equations. It's about solving real world problems, okay? I always say, I can't tell you right here, this kindergarten parent, I can't tell this fifth grade parent, if I just teach your kid this list of skills, your kid will be ready for their job, okay? Because that job doesn't exist yet, right? All right, my son, he's 26, he is he's a data analyst and mathematical modeler for the Mayo Clinic using artificial intelligence. That job did not exist when he was in third grade. Right? Okay? So I couldn't have said, oh, he's going to go do this, right? Because it just didn't exist. All right? So what we know is that problem solving has to be at the heart of everything we do. And that's what we've been working with the teachers on this whole week, is about problem solving and thinking about the process. And some of your fourth and fifth graders who I worked with this week might have gone home and said, that lady told me the answer didn't matter, which I did. I said, I'm not asking you for the answer. I wrote the book. I already know what it is, right? And so what I'm asking you is tell me how you got there. What is your process? Can you explain it, right? My son is successful in his job not because he can do the math, because honestly, Excel does that, or the computer does that, right? But because he can explain it to people who are not mathematicians, right? That's why he's good at his job, okay? So what do we say? We say that it's based on having strong concepts in numeracy, algebra, geometry, statistics, probability, and analysis. Okay, that's kind of the basis of the whole pentagon. On the other side, we say there are skills that we need to help us problem solve. This is where calculation comes in, okay? Barbara Oakley is a professor at San Diego State. She says that we basically have 4 areas of working memory in our brain, okay? If we have to use 2 of them to remember what 6 times 8 is, right? Like if we have to go, well, 5 times 8 is 40, and 1 more 8 is 48. If I have to do that with my working memory, I don't have as much working memory available for problem solving. So the reason math facts are important is not because it's so important, but it's because it frees up our working memory, right? Okay? Yeah. Question?
So for the parents that have younger kids,
Yeah.
this seems to be jumping ahead a little bit. How are you covering fundamentals?
Yeah, we'll get there.
Because whatever way you use there, you still need fundamentals. And I think
Absolutely.
multiplication
Absolutely.
tables, simple.
Yep, that's kind of, yeah, we'll get there. Okay. So that's why it's important, okay? On the other side, there's processes that we teach kids that help them problem solve, okay? Is there a word up there that you don't know? Or you haven't heard of, maybe?
Metacognition.
Metacognition, yeah. Yeah, we'll talk about that one. Heuristics. So everybody know what a heuristic is? That is a problem-solving strategy. So this strategy that she used, this is one we actually teach. It's called bar modeling. Do you see this? It doesn't do the math for you, but it helps you think about the math and what does that mean, okay? That's a heuristic. On the top, you're right, we have a word called metacognition. That means that we want kids to be able to explain their thinking. We want them to be able to monitor their thinking. If they get going, we want them to be able to say, oh, that didn't make any sense, right? I had some kids today working on a grandma problem. It's like, this grandma's this old and whatever. And they're like, well, the grandma was, 21. And I'm like, well, probably not, like what's a reasonable age for a grandma, right? So that kind of thing, you want them to be like, oh, wait, that didn't make any sense. I must have made a mistake, right? Okay. And then on the other side, we want kids to have good attitudes about math. We want them to believe that they are mathematicians. We want them to be interested in math. We want them to have confidence and perseverance when they're solving math problems, okay? So if you ask a teacher from Singapore, and I have a couple of friends that have moved here now, and you say, what's different about teaching in the US and teaching in Singapore? They will tell you American schools got stuck on the bottom. We got stuck checking off a bunch of checklists and saying, oh, kid could do this, kid could do this, right? And then we just kind of hoped that they would be able to think, right? And in Singapore, they actually teach the other way. They say my curriculum is teaching kids attitudes and metacognition and problem solving, and math is a vehicle. that make sense? It's a little bit different philosophy. So we're gonna talk a little bit about how we build that from our youngest to our oldest, okay? And that's kind of where we're headed. All right, so there are 4 things that we do to say we're teaching Singapore math. And this is the same training that teachers had in April or something. So let's just talk about, this thing just does not like me. I've lost it 6 times while I did this week. Okay, so there's 4 things we do to say that we're teaching Singapore math. Are you ready? The first one is what we call the use of the concrete to pictorial to abstract cycle. So the best way for you to learn about this is to experience it yourself, okay? So I'm going to ask you to do me a favor, and I want you to take 6 cubes that are in front of you, okay? And I want you to break them. I want you to count 6 off, so you just need to find 6. All right, everybody's good? And I want you to put them together. We call it making a number train when we talk to the kindergartners. So we want you to make a number train, okay? And then I want you to hold it up over your head. And I want you to close your eyes. And I want you to break it up any way you want. All right, you are welcome to open up your eyes. And I just want to hear from you, what are some ways that you, what are some ways that you did that? How'd you break up your 6? Okay, so some people had 6 and now they have 2, 2, and 2. Okay, anybody do it a different way? Yeah? Okay, so you have 3 and 3 make 6? Okay, good. Anybody do it a different way? Yeah?
I just have 6 individual.
Ah, okay, 6 individual cubes. So you said 6 is the same as 1 and 1 and 1 and 1 and 1 and 1? Okay, anybody have another way? Yeah? You said 4 and 2, 6 is the same as 4 and 2. Anybody have another way? Yeah. Oh, I always say you didn't follow directions. Directions, you have to break it up, but yeah. Because the reason I don't like kids to do that is because then they go 6 and 0, 0, 0, 0, 0, 0, 0, 0, right? And you can do that forever, right? Okay. All right, good. All right, anybody have another way?
1 and 5.
1 and 5, good. 6 is 1 and 5. Any other ways?
3, 2, 1.
Ah, 3, 2, 1. You see what I'm learning about verbs now? 3, 2, and 1. Did anybody have 4 and 2 instead of 2 and 4?
I didn't.
You did not? Did anybody else? Is it possible to do 4 and 2 instead of 2 and 4?
Yeah.
Do we need to do it both ways? What do you think? Yeah, I mean, do you think that, are they the same or different? 4 and 2 and 2 and 4? Okay, so some people are saying same, some people are saying different. So why do you think it's different?
Because the way your brain thinks about it.
Okay, tell me more about that.
Because, like, maybe you think about bringing it kind of in numerical order, so then it's 2 and 4.
Yeah, you're exactly right. I want you to think about this. In this case, I have 2 oatmeal cookies and then 4 chocolate chip, right? In the other situation, I have 4 oatmeal and 2 chocolate chip. This is what I tell the kids. It has the same value. It tells a different story. That makes sense? It has the same value. It tells a different story. We don't want the kids to say it's the same thing. It's not the same thing. It has a different meaning. Just like 3 groups of 5 and 5 groups of 3 have the same value, but they tell a different story, right? Okay, so that's kind of how we want the kids to think about it. So concrete, pictorial, abstract, we say first we build it. Do you see that? This is a story about 10 and 12. First we build it, then we draw it. Down there, you can see where we drew it. And I love this one because the kid's telling us he understands that 10 is less than 12, right? How can you tell? Because he's mad that he only has 10 candies, right? Okay? And then we add the numbers. When we add the symbols, that's the abstract. So every lesson trajectory or every topic in Singapore math goes from concrete, we learn it first with manipulatives, then we draw a picture, and then we finally learn the abstract part, okay? So this is one we just did. That's kind of what it looks like in the book. That's what the lesson might look like. And then, you know, what happens is kids start to develop these alternative strategies, right? So here's a kid who was able to take that and do it for 20, much bigger number, right? And then here's another kid that took it to a whole nother level. You see? Okay, so that's a great game. At dinner, you're like at a restaurant to say to your kid, what are all the ways you can make a 7, right? And if you have an older kid, what are all the ways you can make 2.5? Okay, and just have them go and see how many different ways they can do that, okay? Flexible thinking, that's something we're focusing on. All right, so what happens next? Then we move into being able to help them do some pre-algebraic thinking. This is from first grade. Do you see that? What number goes in the question mark? 3, right? Easy? Okay, ready? How about now? What is the heart worth?
11.
I hear 10, I hear 11, what else? Anything else? 10? Okay, how did you do it? Star is worth what? 4, diamond is worth 6. If we put the star and diamond together, we get 10. Do you see that? See how that's really algebra? Couldn't it have just been X, Y, and Z? Yeah. So we're doing algebra in first grade. Do you see that? We're just using a star or a heart instead. Okay, we're using the same thinking we just discovered right here. Okay, concrete, pictorial, abstract. All right, so let's see what that might look like for something like long division. Okay, watch. You're gonna like this because you're probably gonna learn it this way. Okay, so the problem that we're going to think about is, it's working. The result to draw it. Okay, the problem that we are going to think about is I have a friend who's a farmer, and he was able to grow 525 heads of lettuce this year. And he was lucky enough to get 3 restaurants to buy them, Chipotle, Subway, and Olive Garden. And his job is to figure out how to share his lettuce evenly. He has to give the same amount to every restaurant. Okay, so how might we get started on this? I have 525 heads of lettuce up there. How might we get started on this problem? What is the first thing we should do? Anybody have a thought on that?
Give everyone 100.
Okay, I agree. Let's give everyone, would you mind? You can do that, or just, you do that. Yeah. Give everyone 100. Excellent. Okay, so let's watch how we record this, okay? That's the interesting part. So we have 525 heads of lettuce, and we have 3 restaurants, right? And the very first thing we did was we gave each restaurant 100. So we write that in the hundreds place, right? Okay, how many heads of lettuce did we pass out all together that time so far? 300, right? So we're gonna write, and I know this is gonna look weird to you, we're gonna write 300. That's how many heads of lettuce we handed out, right? We didn't hand out 3, we handed out 300. Okay, how many heads of lettuce are left? 225, because we never gave those out either, right? Okay, can we hand out the 200 heads of lettuce evenly? No. So what are we going to have to do to those? I have to say the kids are boxes of 200 heads of lettuce. What are we going to have to do to those boxes? Break them open. So we break open our, yeah, you just have to, yeah. Yeah, that one.
It's not letting me.
It won't let you? You probably can't do 2 at a time.
Yeah.
Yeah, there you go.
Great.
Okay, there we go. What did we get when we did that? 20 tens, right? How many tens do we have now? All together. 22, look at this. 22 tens and 5 ones. You see that? Okay, so what can we do now? start passing out the tens. Okay, go ahead. I'll just tell you to save you some time that there's 7. Okay, so go ahead. Yeah.
I will help you.
Yeah, go ahead. You need 7. Okay, all right, ready? So there's 7. Each restaurant ends up with 7 tens. How many heads of lettuce did we pass out that time? 21 tens, right? Which is 210. How many tens are left? There should be 1 left.
There should be. Yes.
Is that one,
I
yeah?
did that.
There you go. Okay, how many tens are left? 1 10, and we still have our 5 ones. So what do we have to do now? Break up the 10. Now we have, guess what? There it already was, 15 ones. And now each restaurant will get 5 ones. Okay. How many did we hand out all together? 15. Were there any left? No. 0 remaining, right? 0 remainder. Okay, what's interesting about this is, how many did Chipotle get? 175. How many did Subway get? 175. How many did Olive Garden get? 175. Did we do our job? Did we pass them out? Yes. Where do we see that here? At the top. What did the 3 mean? Number of restaurants. What did the 525 mean? How much lettuce there was. What did the 0 mean? There wasn't any left. Do you see, that's a procedure we all learned, but not why. We never learned why it worked, right? We just learned to do it, but we never actually learned how it related to a real life situation. Does that make sense? So when we teach line division, we teach the why. Then it doesn't matter. I can say to the kids, oh, we're going to do it again, but there's 4 restaurants. What's going to change over there? Right? The 4. What else is going to change? The 175, right? And in this case, probably the remainder, right? Okay, all right. So that's kind of how we use the concrete to help kids build understanding. Okay. All right. Let's go back and talk about. There's our farmer, maybe. Just gave up. Okay. Let's talk about kind of the next big idea, which is how can you help? Sorry. How can you help your kids at home with this? Well, one of the things is they need some manipulatives at home, okay? And I'm not going to tell you have to go like on Amazon and buy a bunch of stuff. You can use things from home. Okay, red and white kidney beans work just as well as cubes. Does that make sense? You can use forks and spoons during remote learning. And a lot of kids were like, I can't find my manipulatives, even though school sent them home. I'm like, go to the kitchen and get some spoons, right? Every kid can go to the kitchen and get their spoons, okay? You can use toothpicks, you can use junk from the garage, right? You can use nuts and bolts. It doesn't matter, but they need to be able to have stuff to use. If your kid comes home and they're like, I don't know how to do this, I'm struggling with my homework, you just need to say to them, did you use some kind of tool today? Was there some kind of manipulative you were using in class, right? And then they'll most likely say yes. And you're like, oh, that's what's missing right now, right? I don't have that at home, okay? So I just want you to know, get them out, have the kids have their hands, do things like Lego, okay? Things where they're building, things where they're using their hands to make sense, okay? All right, so that's how you help with that. The second part is a special tool called visualization. Visualization is when we move it from our hands to our mind, okay? Because we're not gonna go to the grocery store with cubes in our pocket, right? Okay, eventually it has to become mental now, right? Okay, so the main way we do that in Singapore is through a process called bar modeling. It starts in 2nd grade. Okay, some of you guys are probably seeing this now, right? Anybody seeing this now coming home? Let me talk to you about how it starts. So the very first thing that happens is we give the kids a story. Molly has 8 and Lucy has 7. Molly has 8 yellow cubes, Lucy has 7 red cubes. How many do they have in all? And we ask them to build it with their cubes. And then we say to them, you know what? The numbers are gonna get big, we're not gonna use cubes anymore. Could we just draw a picture of it and know that this one is 8 and this one is 7? And it doesn't have to be perfect. As long as the 8 is bigger than the 7, we're good to go, okay? And then they find the total. That's how it starts. Some very simple kind of problems. They do that again in 3rd grade, 4th grade, but they just do it bigger and bigger and bigger numbers, okay? All right, and then let's see see, without knowing anything about bar modeling, this is the teacher's day, I'm gonna see if you can pass the end of year second grade test. Okay, this is from the end of year second grade test, ready? So I just need you to give me a thumbs up or a thumbs down, depending on that statement. Are you ready? Amanda has 30 fewer fruit sticks than Connor. Is that true or false? False. Thumbs down, right? Okay, why? She has more, right? Okay, good. Connor has 50. You might have to do a little math now. Right? Okay, good. The difference between theirs is 30, so he must have 50. Good. Connor has 30 fewer than Amanda. Good. Okay, Amanda has 80. You see that? Yes. Okay, now we get to a hard one. Amanda and Connor have 130 in all. Not true? Not true? Some people are saying yes, some people are saying yes. Okay, all right, let's talk about that one. So we already found out, right, that Connor had 50, didn't we? We already found that out. Okay. So, how can we find out how many they have in all? We can add 80 and 50, that would be one way. Is there another way? Yeah, we know that if that's 50, then this part must also be 50. So then we can just add 50, 50, and 30, which might be easier for a kid than trying to add an 8 and a 5, right? 50, 50, 30, that's easy to do in my mind. Okay, any other ways?
80 plus 80 minus 30.
Yes, I love that way. If they had the same, they would have both had 80, right? So that would have been 160, but he had 30 fewer, so we could subtract the 30 and up the end. Lots of ways to get there, right? I did this problem today with the kids, and they came up with like 6 or 7 ways, something like that, okay? All right, excellent. Okay, so you guys passed second grade. Congratulations. Okay, let's see what happens next. So in third grade then, we go right back to doing kind of the same thing, and we say Anna bought 5 boxes of crayons, and each box had 6 crayons. So the first thing we do is we ask them to build it again, right? And then we say to them again, we're not going to keep using cubes. Can you draw it? Okay, so they draw 5 boxes of 6. Now we have 30, right? Okay. All right, so that's third grade multiplication. And then we get to something like this in fourth grade. Do you remember these problems from high school? Is anybody like getting nauseous right now? Okay, so I hated this kind of stuff. Like this was really hard for me. It is so easy for me now because I use those pictures in my mind. All right, so watch. The sum of two numbers is 36. The larger number is 3 times the smaller. We don't know what the numbers are, right? So I'm just going to say, I have no idea what the numbers are, but this is going to represent the smaller number. I'm just going to use that box to represent it. So what do you know about the larger number? 3 times. So how many of those boxes do I need? 3. So there we go. 1, 2, 3. There's the larger number. Do you see that? What else do we know?
36.
Sum is 36. How many equal boxes do we have? 4, and they have to equal 36 in the end. So how much is each one? 9. What are the two numbers? 9 and 27. You see that works for any problem. I can say it's 4 times as much, it's 1/3 as much, it's a 1-to-3 ratio. It's the same exact model. See how flexible that is? That's where they get to by 4th and 5th grade. So by the time they get to algebra, that is not a scary problem anymore, right? Okay. One more like that. I didn't put it on. Sorry, I have another one I love, but I didn't. Okay, all right, so how can you help this at home? This is how you can help this at home. There are 3 things that you want to look for. One is this letter called School to Home Connections. This should be coming home from your teacher. Okay, there's one for every single chapter. It gives you some things you can do. It tells you about what the kids are going to learn. Then it gives you some activities you can do and things to talk about math. So if you haven't seen those coming home, you might ask. Lisa will probably send out a reminder tonight and say, hey, we told all the parents these are coming home now. So, like, remember, they're new to it. They just started, right? So okay, I think they have been sending them. Yeah.
Is that in their workbooks or that's like completely separate?
That's separate.
Okay.
Yeah. And I think, well, you know what? If you have the extra practice book coming home, it is in there. It is, yes. But if they don't have those, then it's separate. So I think it might depend on how they're sending it home.
They're sending it home individually.
They are sending it home individually. And some of them might just be attaching it to their newsletter or something because it's editable. So they might be sending home a different way. But okay, the second thing is this really amazing free website called mathplayground.com/thinking blocks. Thinking blocks is a whole game thing about these kind of what we call bar models, okay? And not only are there these fun kind of game modules that the kids can play through and you can play through if you're trying to learn it, but there's parent videos underneath that explain in more detail about the models. Okay, so you can learn about it yourself. Because did anybody here learn with those? No? Yeah, not yet, right? I just, like 2 weeks ago, had my first teacher in a training who had learned them. So that was kind of exciting, like the teachers are finally like young enough, you know, like they're coming up that they finally, I'm getting some teachers that taught it. So I was like, oh, that's great. I finally, and it was totally different, right? Because it wasn't new to her. She grew up with that, she knew it already, okay? And then the last thing is this really great website called Solve Me Puzzles. It's a pre-algebraic thinking website, and I really highly suggest it for everything from kindergarten all the way through. It took me personally 2.5 weeks to solve the last problem on there, okay? Which was an expert problem, yeah.
You know, I know you mentioned that this is a new location.
Yes.
But like, aren't most of the teachers familiar with already most of this?
They are familiar with the pedagogy, but the focus, there's a much higher focus on higher order thinking on this one. So that's really what we're talking about, is like how do you build for higher order thinking? One of the kids today said to me, oh, I guess it's really about how I did it, not what I got. And I was like, yeah, that's exactly right. Okay, that's what we're going for. So yeah, they're still getting the right answer, but that's not the focus, right? That's not, I don't care about that as much as I care about them telling me. Okay, it's still important, we're still gonna go over that, but like you can't be inaccurate, right? That's not good either.
Do you have strategies for like helping to help your kid learn how to tell you what they did? Because I like ask them nicely.
Yeah, actually, I'm gonna give you 5 questions to ask them at the very end of this. That's not the very last thing we're gonna talk about is questions you can ask your kids when you're trying to help them, to get them to tell you better, okay? And I'll talk to you about what specific questions you can ask, okay?
You know what, Susan,
Yeah.
I totally forgot to tell them, I'm so sorry. On
Yeah.
your table, there's like a QR code thing, there'll be a time for questions at the end. So if you're having questions, like, well, please feel free to throw them in. And we'll either, if we don't address them directly, one of us will reach out to you.
That's right, yeah. So
Yeah.
that's another way to get questions answered too, yeah. Okay, so variation is the third big thing, and this is what I want you to think about. Variation is not the same thing as variety. So what color do you see right now? Purple, and this is also purple, and these are all shades of purple, right? Okay, that's what we're talking about. We use something called variation, and this is how you build mastery in a skill, okay? As opposed to this, which is variety, when we throw 100 things at a kid, okay? All right, so let me just talk to you a little bit more about that. It has to do with our memory, okay? So I like to tell the story of I took my kids to London right before the pandemic, and we get to the hotel, and I go up to the desk and I'm like, can I have a map, right? At which point my teenagers are going, so embarrassed, right? Like they didn't want to know me. And I said, I like to have a map because I like to see it, you know, I like to see the whole thing, right? So the last day we're there, we're going to the tube station, and I said, okay, well, let's go to the tube. And they're like, oh, getting out their phones, you know, to go on Google Maps. I said, you don't have to do that. We're just gonna walk down the street. When you get to the church, turn right, and the tube's right there. And they're like, how do you know that? I said, because I've been looking at it. Right? Okay. What happened was my kids developed what we call instrumental understanding. Okay? Instrumental understanding is when we have pockets of things, but we can't put them together. So we know this and we know this. It's kind of how Google Maps works. You know where you started and you know where you got, but you kind of didn't really pay too much attention to what happened in the middle, right? Right? Okay. And relational understanding is what I developed. I could get from point A to point B, but I also knew all the pathways in between. Does that make sense? Our goal is to build that for kids. Okay? And this is why. I want you to think about if you shoveled a path from your front door to the mailbox after a big snowstorm. It's easy to use this example in Chicago, by the way. Okay, so we did that, right? And I'm from Denver, so it's easy for me too. Okay, and what happens if there's a windstorm overnight? The path is covered and you can't get to the mailbox anymore, right? Okay, that's why we need kids to have multiple pathways, right? The more ways they can get there when they get stuck, they have alternatives. Okay, So the way we do that is through something called variation. And let me just talk to you about it. There's two kinds. The first kind is called perceptual variation. So this is from kindergarten. We want kids to understand that there's all different ways we count. You see, we can count horizontally by ones. We can count vertically by tens. Do you see that? We can count in groups. Do you see that at the bottom? We want kids to do, we say mastery comes from doing one problem 5 ways instead of 5 problems. Okay? So that's the first way, is when we look at things differently. Here's one from 4th grade. First, we teach them 13 times 5 is 5 rows of 13 dots. Do you see that? Then we say to them, as the numbers get bigger, you don't want to draw these dots anymore, right? It's too much work. Okay, so in kindergarten, you learned that 13 is 10 and 3, right? So what's 5 tens? 50, and what's 5 threes? 15, and you could just put those back together and you have 65. You see? And then we say we don't need the dots to do that, we can just do it over here with just drawing some boxes. We could say 13 times 8 is the same as 8 times 10 plus 8 times 3. You see that? Now I can do something that I would have needed paper and pencil for before, but now I can do it mentally. See that? Because we've taught them 2 different ways to do it. Okay? The other way is called numerical variation, and this is when we keep the numbers the same, right? The model's the same, and we change the numbers. So we can say to kids, if you know that 2 groups of 3 ones is 6, 2 groups of 3 tens is 6 tens, and 2 groups of 3 hundreds is 6 hundreds. 2 groups of 3 thousands is 6 thousands. Do you see what I mean? We start to build these patterns for kids. Okay? Or here we might say, oh, okay, what if we multiply a 2-digit number by a multiple of 100? Right? We learned this rule that we can multiply the 3 times the 23 first, right? And then multiply it by 100. Which for us, we learned that as stick a couple zeros on the end. Right? Okay? All right? And then we say, oh, does that still work if you have a 3-digit number? Oh yeah, the rule still works. What if you have a 2-digit by a 4-digit number? Does it still work? Yeah. Oh, what if we have a 3-digit by a 4-digit? Does it still work? Yeah. Do you see what I mean? And they start to build kind of this patterning. Okay? All right, so that's the next way we do that. So how do you do that at home? This is my daughter's at Northwestern now. That was a long time ago, obviously. She's a sophomore down the street. Okay. And how do we do that? Well, this is how we do it. We play games that require variation. These are all amazing board games. If you don't have it at home, Uzzles by far my favorite of those games. Does anybody have that game at home? I really, really, really recommend it. It works for all ages. A kindergartner can play it, and an adult can still feel challenged by it. Okay? Oshi is another one. Evolution, Moncla, chess, Ken. All those things are games that build on variation.
The Arlington Heights Memorial Library also has a lot of them in their library of things.
And you can check them out. Oh, that's awesome.
I know because I requested a lot of them.
Yeah. That's great. Okay. And then there's a bunch of activities you can do with your kids. Make mosaics, do sewing things, have them play music, organize the cabinet. My daughter's, one of her favorite activities is to organize the spices. Still, to this day, at 19, she still likes to do it. Okay? It's just to think about what are the different ways they can be organized. By color, by name, right? What are all the different ways you can do that, right? Okay, find patterns in nation. If you haven't done geocaching, have you guys ever done geocaching? I highly, highly recommend it. It's completely free. You use your phone or a GPS, and there is literally treasure buried all across Chicago in places you might not know. It's very interesting. So that's something I really recommend you do with your kids. It's super fun, outdoors, okay? And I won't tell you too much more because I'll ruin it for you, but it is really awesome activity. Are nodding, right? That's a good activity, okay? All things that support variation. Okay, last thing. We want kids to build from lower level thinking to higher level thinking. So there are 4 levels of thinking, okay? The lowest level of thinking is what we call recall and reproduction, and that is just a straight memory task, okay? So I like to sometimes use this example. My daughter took this class in high school, and you probably took it too, but it probably wasn't called this. So let's see if you can figure out what it was, okay? It was called Culinary, Interior, and Fashion Design. What was that class? Home ec. She took home ec, but her high school has a big fancy name for it, okay?
This is great.
Isn't that great? Yes, looks better on transcript, I guess, okay? So anyway, anyway, she took that class, right? And a recall and reproduction type of question would just be something like, label the parts of the sewing machine. Which is very low level, right? You don't really need to know how to sew, to just label the parts, okay? The next level of questioning is what we call skills and concepts. And that's when it requires you to use some kind of skill. So we might say something like, label the parts of the sewing machine in the order that you thread it. You see how now I'm assessing that skill, okay? The next level up would be a strategic thinking when the kids have to apply a strategy. So it might be something like, if you are sewing on silk, what tension would you use? Or what stitch would you use? Why did you choose that? Now you have to apply some kind of strategy, right? Okay. The highest level of thinking is to put it all together with something you've never learned before. So it's to go beyond what you were taught and extrapolate, okay? So in my example, it might be something like, is it even important to teach sewing anymore? Is it a valuable skill anymore? Justify your thinking. Okay, they didn't talk about that in class, but if a kid knows a lot about it, they should be able to answer it. Okay, why do you care about this? Well, math and focus tests. They'll be coming home, chapter 1 pretty soon here. They assess all of those levels, and not very much at recall and reassessment. They pretty much start at skills and concepts. That means the teachers are getting information about recall and reproduction just from their daily work, like do they know their times tables, that kind of thing. But there are questions on every test that assess that higher order thinking. Like we saw on that first graph where we said, what is Singapore really good at? They're good at the top two. Strategic and extended thinking. Okay, so when your kids come home and they say, there might have been a question I've never seen before, you can say, yes, there was. That was on purpose, okay? And it's not because we're trying to trick them or something like that. We're trying to push them to extend their thinking, right? So we're trying to push them beyond mastery, does that make sense, into extension. So at the beginning of the year, it's important for you to know, especially for the older parents of older children, not the older parents, that would be mean, but for the parents of older children, it means that you might get a question home that, they got 1 out of 5 on that part of the test. It's a problem-solving quiz, they got 1 out of 5 on it. That's okay at the beginning of the year. They're just learning. They're developing. Does that make sense? And our goal is to get them to 3 or 4 or 5 points by the end. So part of the test you're going to see, really, they should master, they should get 80% of the questions right. And then there's this last part that's about problem solving, and they're just developing that skill. Does that make sense? And I just want to warn you about that, because as a parent, you get something home that's like, oh, they got 1 out of 5 of them. You're like, oh my gosh. But what that means is they're just developing that skill. They're just beginning to be able to do that. Okay? And by the end, they'll be able to do that better. Okay, so I just want to warn you at the beginning of the year, there are specific problems that the kids will do to prepare them for that kind of thinking. Some of them are called the think problems. They do one of those every single day. Okay, they're pretty hard, right? We did one today that teachers were like, ooh, this one's really hard in 5th grade, okay? They're really good problems. And then there's a whole part of the book called Put on Your Thinking Cap, where they work on specific problem-solving strategies. So this one happens to be focused on looking for patterns. Okay, so they will be encountering lots of these good thinking problems. What you can see is that in kindergarten, they work on 4 strategies: acting it out, drawing a picture, looking for a pattern, and making a list. So if your kid is struggling with those problems, those are the 4 things you could ask them to do. Act it out. What would that look like if we acted the story out, right? What would it look like if we drew a picture of that? What would that look like? Okay, how does this pattern look? Do you notice something? Do you notice anything about these numbers? Okay, and then you can see by the time they get to the end of 5th grade, they have a whole lot of these strategies in their pocket. Okay, so by the time they get there, they've learned a ton of different ways to approach those problems. All right. So remember, I promised you those questions. Here you go. This is how you help your kid build these skills. The first way is when you ask your child a question, make sure it's plural. So you want to say to them, what are some ways you could do this? Instead of saying, how did you do it? You want to say, what are some ways you could do it? Okay? The second way is to make it tentative. Use might or could, right? Like, how could you do it? What might we do first? What's possible here? Okay? The third thing is to ask open-ended questions. That's pretty self-explanatory. It shouldn't be a yes or no question. Okay? And then the fourth way is to use words like compare this to something, predict, what do you think is going to happen? right? How do we evaluate our answer? How could we tell? Those kind of things. And the last way is my favorite one. Presume that they know. Okay? So this worked really well with my daughter. I would say to her, she'd be like, I don't know how to do this, right? Especially in AP pre-calculus, or whatever it was, pre-calculus. She'd come up, she'd be like, I don't know how to do this. And I'm like, well, you're out of luck because I don't know how to do it anymore either, but, right? But I'd say, but if you did know, what would you do, right? And she'd be like, oh, well, I would do this. Every time she said that to me, I don't know how to do it. I said, well, if you did know, what would you tell somebody? And then she would tell me how to do it. Does that make sense? It worked really well. It works really well. So just presume that they did. Like, when you noticed that pattern, what did you see? See how you're giving them the message that they noticed the pattern? Okay? So that's the other way that you can ask your kids better questions. Okay, did that help a little bit, hopefully? All right. Last thing I want to share with you before we answer some questions is what a lesson looks like for your kids, okay? So if you were to walk into a classroom in Arlington Heights right now, the very first thing you would see is the kids and the teacher notebooks. The books are closed. The kids and the teacher talking about a good problem solving together, okay? The very next thing you would see, we call that an engage. The very next thing you would see is the teacher facilitating, the book's still closed, a conversation about the math, okay? The very next thing you would see is a bunch of kids working together in their books and trying to solve problems together with a partner or a small group. And then the last thing you would see is a kid trying it on their own. At the end of that stage, the teacher has to decide who needs more help and who's ready to move on. And so every lesson, there's an opportunity for them to say, here's some kids that need more extension, here's some kids that need more support, and then they work with those groups of kids. Does that make sense? So they do that every single lesson, okay? And they kind of decide at the end of that practice. And that might change from day to day. It might be one lesson, this kid's the kid who needs more extension, and another lesson it might be this kid who needs that. So they're making those decisions every day. The program comes with an entire book of extension and an entire book of extra support. Okay, so they have that for every single day. All right. So let's take a few questions and then we'll wrap up with that lesson. So, does anybody submit any?
Not yet.
Not yet. Does anybody have any? Yeah.
Were these the questions that were being asked in the math testing?
No. Map testing is a national standardized test.
Okay.
Does that make sense? That actually adjusts to your kids' level. So what happens is they go in, the first time they take it takes a little while because it's trying to find their level. And then as they're getting questions right, it actually gets harder. And as they start missing that, it gets easier and it tries to find their actual level. It's called an adaptable test.
Okay.
Okay? And it's very highly predictive of state testing. Very highly predictive. I work in Barrington, with Barrington also. And we just did a whole study of that in the middle school on Tuesday, and it was almost exactly the same. It said like 52% of kids are proficient on math, 52% of kids were proficient on state testing. It was very, very interesting. Whatever, it was very, very closely aligned. So we use it for that to help us know, like, do we need to make an adjustment? So they take it, what, 2-3 times a year? Yeah, and they just took the fall one, then that kind of gives us a little bit more information about them, but it obviously doesn't test like open-ended thinking, because it's all multiple choice.
Okay.
Okay, so it's not like they're explaining their thinking or anything like that in that test. And then what happens is it helps the teachers kind of figure out who needs more support, right, who needs more extension. Then they take it again in the winter. We get more information, we can adjust again, they take it again in the spring. 3 times a year. Starting in 2nd grade or kindergarten or kindergarten. Okay, yeah.
So we're new to the district.
Yeah.
I don't think our last school used this. So is it difficult for kids to jump in and say in 3rd grade and you go, oh, this makes sense?
Yeah, so every single chapter starts with an assessment of prerequisite skills. So the teachers are orienting to that, and they're using it for everybody now since we switched editions anyway. Like we're trying to make sure that the kids have the prerequisite skills from the previous grade, and it's actually built into the pacing. So the first lesson of every single chapter, they take a prerequisite test. And then the teachers decide if they need to do like a little bit of pre-teaching before they can jump into the chapter or not. So they're assessing that for every kid, every chapter, anyway, starting in 1st grade. So kindergarten, we don't expect them to know anything, so we don't have to worry about that so much. Blank slate, yeah. Did you question?
I was wondering
Yeah.
that you put up there, because my daughter didn't bring home a ton of homework last year, but so anyways, my question was, I don't know if maybe they were doing some of those in class, but they were never doing them.
That is very possible because, yeah.
I was like, why aren't we doing these questions?
I see. So yeah, they might have been doing them in class. Sometimes we do them like on whiteboards instead of in their book. Or we ask them to work on a group with them because they're pretty hard, right? So you might not, your workbook might come home with that empty, but that doesn't mean they didn't do it. It might mean that they did it in class, like on these boards instead, so that they can work with a bunch of kids on it. And that's what actually normally how we would do it, is like 4 kids together thinking about it because they're pretty hard. Yeah, so that might be that. But that doesn't mean you can't give it to her. You know, in the workbook, you want to keep working on a couple of them, you're definitely, good to do that. Yeah. All right, let's do this. One more question. I know it's time to go, so, yeah.
So one of your slides, you had a pentagon.
Yeah. It was a pentagon.
Okay, it started with the meta cognition.
Yes.
And you said in second grade math, they teach from top down.
Yes.
So the idea is you were kind of, tree versus forest, and explaining what the forest is and measuring the tree.
Yes.
But then you showed a triangle, a pyramid, and it went the exact opposite way. We are teaching them how to recall and.
No, I think, yeah, I see what you're saying, but this is really just saying that that's the basis, right? You have to be able to do that before you can do the next thing, before you can do the next thing. So it's kind of like, if you can't remember it, you can't apply a strategy. Does that make sense? If you can't, if you don't have the skill, it's hard to do a strategic thinking. So these are like prerequisites.
On each other.
Yes.
So does this still imply that they are memorizing the times table?
Yes.
Before they can make it?
They are. I mean, or they have a strategy to get it, even if they don't have it memorized. Right? Yeah. Like I said, my daughter goes to Northwestern, so it obviously didn't affect her. If you ask her what 6 times 8 is right now, she will say 5 times 8 is 40 and 1 more 8 is 48. She never learned that fact for some reason, ever. She was on an IEP, she was a learning disability. She never really was fluid with her multiplication facts. She got an 800 on the SAT math, because after a while it just doesn't matter. She got a calculator, it didn't matter anymore, and she's a sophomore at Northwestern. And I could be a godmom for a minute, and she went top freshman last year. It didn't affect her after a while. Do you see what I mean? So we don't want that to become an obstacle for kids after a while, but we don't do that till like end of 5th grade, where we say, we taught it to you in 2nd grade, 3rd grade, 4th grade, 5th grade. For some reason, your memory, your neurodivergence, whatever it is, you can't do it. Your memory doesn't work that way, it's fine. We'll give you a calculator, we don't want to hold you back anymore. But we wait till like 5th grade, we try to give them as many opportunities as we can. But there are for sure kids who just, don't have it. I'm sure there's adults in this room who still, for me it's 8 plus 5. I don't know what it is, I can't add 8 and 5. In my head I have to go, 8 plus 2 is 10 and 3 more is 13. Every single time I do it. Right? I don't know what it is about that fact, I never could be fluent enough. So, at some point this will get your way. We don't want to hold kids back that have a memory issue that's like something that's just inherent to who they are, right? Okay.
These are just confused about teach metacognition at that level.
Yeah, well, we asked them, how did you know that? How did you know that 3 times 2 was 6, for instance? How did you know that? We say to them, well, then they should be able to prove it. Okay, that's 3 times 2 gets 3 groups of 2. You see what I mean? That's how we have them explain their thinking. Okay. I am happy to stay and answer some other questions, but I know it is time for you to go. You're welcome to scan that if you have questions later, or take one of those, I guess, if you want to scan a question later. But I really thank you for coming out. Lisa,
yeah, thank you guys so much for your partnership and for coming out. It is so important to me that every kid in District 25 feels like a math kid, and it means like a very lot to me that you all took the time out of your day to be here. So thank you very much. Thank you, Susan, for spending time with us today. If you need anything, please reach out. Thank you.